Okay, so this is going to be a replacement lecture as I'm not going to be here on May 17th on Thursday. So what we are going to look at in this video is factoring and solving equations. This is actually a review from pre-calculus topics. So I'll just put review. And then critical numbers and local max and min. So before we do the factoring part, let me just talk to you about a graph. So if we had a curve like this, then this, which I call a hill, so the top of the hill, the point at the very top of the hill, is called a local max. And at the bottom of this valley, we would call this a local minimum. Now, a local max and min are found at hills and valleys. Okay, they're not necessarily the highest point on the graph. Like you see, this goes up higher, so it would be higher than the max. Over here, that's not a local max or min. So local, it kind of means like in the area that point is. So around this point in this sort of neighborhood, that point at the top is the maximum. And the same here at this, in points near here, this is the minimum. Okay, so we're going to use critical numbers, which are found using a derivative. But first, let's do a review of the topics we need. Okay, so solving for x. So first we could get a linear equation and set that equal to 0. And if we wanted to solve for x, we could rearrange that equation. Move the 1 over to the other side. It becomes a -1. Divide both sides by 2. So x equals -1/2. So that's when it's linear. We could also have something like this, and what we would do first is multiply that 3 throughout the bracket. So this would be 3 times x, and 3 times 1 is -3, and then we would solve in the same way we did over here. 3 divided by 3, which is 1, so x equals 1. Okay, so that's for linear equations. Now for quadratic, we're going to see a couple different factoring techniques. So factor or use the quadratic equation. So you do have to memorize the quadratic equation. Let me write it down. Okay, and factoring, we're going to see 3 types. Common factor, difference of squares, and factoring trinomials. Okay, so we're going to see those different examples, and if we can't factor or don't want to factor, we can always use the quadratic equation. The quadratic equation solves equations that look like this. Always equals 0 on this side. You would plug your a, b, and c in, and then it finds your 2 x values that will work in that. Okay, so we're going to see these 1, 2, 3, 4 techniques. And let's call that 4. 5 are examples that have no solution. So you can try to factor, won't factor, use the quadratic equation, and this is a negative under the square root, which would mean it has no solution. Okay, so let's see some examples of that. You may know all of this already because it is a review of pre-calculus. So we're just going to do examples and see different things in the examples. So I'm just going to say solve for x as the instruction and give you an equation. Okay, so this first one, say number 1, is a common factor example. So how do I recognize that? Well, basically you're always looking for a common factor. So you say, here's the two terms, do they have something in common? Yes, they both have an x squared. And when you're pulling out an x squared from each, you're dividing. So 2x cubed divided by x squared. 2 of the x's cancel and we're left with 2x. Same here, minus 3x squared divided by x squared. The x squareds cancel and you're left with minus 3. Once you do that, we've got now two what we call factors. Here's the two factors. We set the first one equal to 0, that gives us x equals 0, and the second one equal to 0 gives me 3 over 2. So this has two solutions that when you plug them into this original will give you 0 as an answer. Okay, so we're going to look at this type, which is a difference of squares. So a difference of squares is when you have x squared minus a squared, two things that you can take the square root of, equals 0. So to factor that, we do x, I'll just write it here, x plus a, x minus a. So basically the x is the square root of x squared, and the square root of 9 is 3. One with a plus and one with a minus. It doesn't matter which you do first. And then again, we've got two factors like we had up here. So x plus 3 equals 0, or x minus 3 equals 0. And there's your two answers. Now, looking at that one a different way, sometimes you'll get an equation like this, x squared equals 9. And what you were taught to do probably is to take the plus or minus the square root of 9, which is fine. You get the same answers as we got here, plus or minus 3. It's actually the same equation. If we looked at this equation and brought the 9 over to the other side, it would be a difference of squares. Okay, so they are the same equation. I tend to like to factor better because a lot of times people will forget their plus or minus and then just get one answer instead of two, and then we're doing something with these, so you really don't want to lose one part of the answer. So when we're factoring, one important thing is that this is always equal to 0. Okay, and then that's a difference of squares. Sum of squares can't be factored. So that would maybe look like x squared plus 9 equals 0. This can't be factors. There's not two factors that multiply to give this. If we tried to solve it in the way I did up here, if you move that 9 over, you get minus 9, and then when you go to take the square root, a square root of a negative has no solution. So sum of squares has no solution. Okay, so here's the trinomial. So if you remember how to do this, this is when there's an x squared, an x, and then a number. And they don't always factor. I'll show you the second example that doesn't factor. This one will. So if we want two numbers that multiply to give 6, so we want two numbers to multiply to give negative 6. And because that's a negative, we want the same two numbers to subtract to give negative 6. And I know it's subtract because of that negative sign there. Okay, so if that's a negative, then we want to subtract. So two numbers that multiply to give 6. So it could be 6 and 1. They multiply to give 6, but they subtract to give 5. Oh, sorry, we don't want to subtract to give negative 6. We want to subtract to give whatever's here. This should have been a plus 1. So 3 and 2, those also multiply to give 6. And they subtract to give 1. So in order to subtract to give a positive 1, because there's a positive 1 here, this would be plus and minus, and they multiply to give negative 6, and they add to give a positive 1. Or they subtract to give a positive 1. Okay, so this would be x plus 3 and x minus 2. And that's your two factors. So x plus 3 equals 0 gives me negative 3. And x minus 2 equals 0 gives me x is 2. So those would be my two solutions. Okay, so let's just do a couple more of these, and a couple that don't work, and a couple that we need the quadratic equation for. So whenever I get a number in front of the x squared, I just jump right to the quadratic equation. You can try to factor it, and there is a technique to do that. But so here we have a equals 2, b is negative 3. Don't forget to take the sign with it, and c is 1. So negative a negative 3, because that already has minus in the formula. B squared is negative 3 squared minus 4 times A times C. So we have 3 plus or minus square root of 9 minus 8 over 4. Square root of 1 is 1. So how do you get your two answers from here? Well, the first one is 3 plus 1 over 4. Or 1, and the second one is 3 minus 1 over 4, or 1/2. And so our answers are 1 and 1/2, or 0.5 if you'd put it in your calculator. Okay, we'll do that again. So here A is 3, B is 2, and C is 4. So minus 2, B squared is 2 squared. Okay. So what we get in the square root here is 4 minus 48. And so you notice under the square root, that's a negative. So there's no solution. And that's all you'd say. There's no numbers here that we can put in that will give us a 0. Okay, so for this one, we want two numbers that multiply to give 8. And because that's a plus 8, we want them to add to give 6. So 4 times 2 and 4 plus 2. 4 and 2 multiply to give 8, and they add to give 6. And so these are our two numbers. Okay, so that's sort of a quick course in factoring. We're going to see more because we're going to go into critical numbers where we have to do this, but I just wanted a quick review some examples just by itself. Okay, so what we're going to look at next is the critical number part. So I'm going to start a new video for that.